Hello everyone and welcome. My name is Venkat and today we are going to explore the fundamentals of data engineering. The goal of this session is not to make you experts in data engineering. Instead, I want you to understand where data engineering fits into the wider data ecosystem, why it exists, and how it creates value for organizations. By the end of this presentation, you will understand the data engineering um, life cycle, and modern architectures, security considerations, and the skills needed to become a successful data engineer. So here is our roadmap for today's session. We'll begin by understanding why data engineering exists and how the field evolved. We'll then explore the data engineering lifestyle, which the which is the core framework used throughout the industry. Sorry, life cycle, which is the core framework used throughout the industry. After that, we'll discuss architecture, security, and privacy before finishing with some practical takeaways and a small career advice for aspiring data engineers. Before we talk about tools and technologies, we need to understand the foundations. One of the biggest mistakes people make is believing data engineering is simply moving data from one place to another. However, the reality is data engineering is about creating systems that transform raw data into trustworthy information that people can use to make valuable decisions, and we are a very important part in adding value to business decisions. So have a think. Let's start with a question. Why do most AI projects, dashboards, and analytics initiatives fail? The answer is rarely because the AI model is poor. More often, it is the poor data quality, missing data, slow pipelines, lack of governance, and or unclear ownership. Many organizations spend significant amount of money on data analytics and machine learning, but forget to invest in the foundations. That is where data engineering comes in. So let's have a look at them. So poor data quality, missing data, slow pipelines, no governance, and no ownership. So let's have a look at the hierarchy as well. So there it is. So the learning of the hierarchy. So you collect data more slow, but then you explore or transform, aggregate, label, learn and optimize, and then you go for the deep learning. So I often say, without data engineering, data science is just a PowerPoint presentation, because without reliable data, even the best models and dashboards become useless. So you must have seen this happen in the place you've been working, or at some place where your experience uh, tells you that good data is the key. How many of you heard Hadoop mentioned but never actually used? Okay, so when did data engineering start? Did it appear overnight? No. So let's have a look at the roots to go back to 1980s, when organizations started building data warehouses using relational databases. So let's look at the timeline. In 1980s, data warehousing, relational databases, and 1990s. That's when it started to be seen as a rise of business intelligence and reporting systems. And during 2000s, Hadoop and big data emerged. And in 2010s, its cloud platforms emerged, transforming industry by making scalable infrastructure available on demand. Today, in 2020s, we focus less on individual tools and more on managing the entire data lifecycle. So, how many of you have heard of Hadoop but never actually use it? So, that's a question for you. So, look at the snapshot if you already had a think about it. And now the trends, you can see the big data has got a good traction at one point and then started dying down. So these happens to most of the technologies, but the actual concept doesn't die down. And have a think of the last time you have used a good data engineering tool, but you have not thought about it as a data engineering tool. So what is the definition? A simple definition is building systems that turn raw data into trustworthy information for analytics, reporting, and machine learning. So notice that the focus is in technology, the focus is trustworthy information. A successful data engineer ensures that the right data reaches the right people and the right time. So that's where your focus must be. Okay, so if for a simpler form, so data from various sources can be moved into can be manipulated by a data engineer, and then which then lead into the data science and analytics. So what does data engineer actually do? So which skill is more important? Is it SQL or communication? Or many people think the engineers spend all day writing SQL, while technical skills are important. Business skills are equally important. On the technical side, data engineers use SQL, Python, cloud technologies, databases, and automation tools. On the business side, they understand stakeholder needs, reduce risk, improve reliability, and help organization to make better decisions. Okay, so this is the technical side of SQL, Python, ETLs, ELT, and cloud databases, automation. So business understanding stakeholders, deliver reliable data, reduce risk, and enable decisions. So let me ask you a question. So which is the most important, SQL or communication? Again, and the reality is both are critical. You can build the most advanced pipeline in the world, but if it doesn't solve a business problem, it has a very little value. So this is modern data. This slide introduces the most important concept in today's presentation. Everything in data does fit somewhere within this life cycle. The life cycle consists of generation, storage, ingestion, transformation, and serving. Think of it as a journey data takes from creation all the way to business value. If you remember only one thing from today's presentation, remember this cycle. So this is the core framework. You can look at this like the generation, storage, ingestion, transformation, and serving on this. So now let's start at the beginning. Go back to the beginning again. So where does data come from? So the generation side. Data can be generated from websites, mobile apps, sensors, databases, APIs, customer transaction, and user interaction. So, and then now let's think about a fun example where the Netflix has a play, pause, search, and watch. So there, the data is just, that's a source of data. So, so every click on Netflix, every click on Uber booking, or every Amazon purchase, everything captures data. So data engineers need to understand the source systems because poor data quality at the source creates problems throughout the entire life cycle. So now look at this other example where the user in at the atomic transaction in a bank, the bank account using OLTP. So if you have a look, just goes into account A and account B, and then they understand how much balance is left, and so that is initiating a data collection point. So that's a source of data. Now let's see how is it stored. Okay, once data is created, we need somewhere to store it. This might be a traditional database or a data warehouse or a data lake or a modern lakehouse architecture. So let's use a simple analogy. So if data is food stored in a fridge, without proper storage, everything else becomes difficult. The storage decisions we make affect performance, scalability, cost, and future growth. So that's why if we look at this simple analogy, uh, where does it live? So it lives in databases, data lakes, warehouses, and lake houses. So the choice depends on what we are storing and what we require and how much we wanted to spend. So now there are some in late 1980s, there is data warehouses, and 2011 there is data lake, and so you can see that different types of data is being extracted and stored depending on the needs of the business. So in 2020s, the lake houses emerged. So this is where the data is stored. So it shows the evolution. So next, moving on, we're getting to the ingestion stage where once data exists and storage is available, we need to move data. So this process is called ingestion. There are two common approaches: batch ingestion, so moves data at scheduled intervals; streaming ingestion, so which moves data continuously or near real time. For example, a bank generating overnight reports may use batch processing. Fraud detection system often requires streaming data because decisions need to happen immediately. So those are the two examples that you can see on this slide. So the source system and data ingestion and goes into storage. So that's how data is moved. So next step is transformation. So raw data is really useful. So because it just gives you the complete information, and the transformation converts raw data into meaningful information. So, for example, thousands of sales transactions may be transformed into monthly revenue figures. So these, at this stage, often involves cleaning data, standardizing formats, applying business rules, and creating metrics. Transformation is where data starts becoming information. So this is where the business insights come into play, like monthly revenue, customers, profit margins, etc. So now if we go to the orders, inventory, and marketing, so source systems, and then it is transformed, and then it can be shown as sales, marketing, and purchasing data maps. So that's where the transformation can be. Now serving, this is the final stage, is serving. This is where data reaches people and systems that need it. Examples include business dashboards like machine learning reports and reports, machine learning models, operational applications, executive decision-making tools. So data has no value setting in storage. Value is only created when someone uses it. So you can have a look at this example where the Google is collecting data and then it shows on a dashboard, which brings meaning to that. So data architecture. So never shoot for this is my advice, so never shoot for best architecture, but rather find the least worst architecture. So that's everything is so this slide shows how everything fits together. So data architecture describes how all the components connect. One of my favorite quotes is never shoot for best architecture, but rather the least worst architecture. So there is rarely perfect solution. So data engineers constantly balance cost, complexity, scalability, performance, security, and maintainability. So good architecture is about making sensible trade-offs. So there is always a trade-off for one to the other. So operational, for example, if the data architecture is mainly to focus on operationals and then what is needed, and then technical is how it is done. So the choices have to be made sometimes. So what it delivers. So for example, if good architecture principles are scalability, reliability, simplicity, and security. So now moving on to part 3, it's very important. Security is not optional extra. Data engineers protect trust. That means implementing access control, encryptions, monitoring, auditing, and governance. So think about healthcare. Ask yourself, would you ever want a company to access your medical records? Have a think. So security exists to protect people, organizations, and sensitive information. So that's part of your role is to do that. But there is obviously there's a greater reach for that. So it's just you have all of us have to think about it. So data engineers, as we discussed. So there's a engineers protects trust by providing least privilege, encryption, so access control, who need to access, and auditing and compliance. So these are the 4 important topics in the data engineering in protecting the trust. You can see it's another scenario where the facial ID, mobile security, so tracking, who is accessing, so these sorts of things. You can have a look at this. So like a practical example, imagine a customer clicking a product on Amazon. The click generates data. So the data is stored, ingested into a platform, transformed into meaningful information. Finally, it is served to recommendation engines, dashboards, and machine learning systems. So before that, we need a lot of security for it. So now let's consider a real world example. So now event. So if you visualize how the previous example is collected, so there is an event stream, storage, transformation, dashboard, and recommendation. So this is when the product is bought by a customer. There is a lot of data generated. So from there, a recommendation is created to cause to buy another similar product or find out the customer's behavior. So you can think of other examples. For example, try and think about Netflix, and so that Now you can imagine where we as data engineers fit, like in the life cycle of, or in the stages of the life cycle, and all we have learned in the life cycle can be implemented in each stage. So final takeaway. So as we finish, I'd like you to leave you with 5 key messages. First, data engineering is about delivering value, not moving data. The life cycle is more important than any tool. Data quality beats fancy technology. Security is everyone's responsibility. Great data engineers understand both technologies and business. So the final question is, if AI disappeared tomorrow, would data engineers still exist? Have a think. Yes, because organizations still needs trustworthy data to make decisions. So thank you for your time, and this is my LinkedIn. Please feel free to get in touch. I hope this has helped you, and this is just to create a little thought process about data engineering. It's not complete data engineering, but it is more to give you an insight about what is expected.